This is the United States Energy Association Power Sector Podcast. I'm your host, Herman K. Trabish. I've covered the power sector since 2006, and I currently report for Utility Dive. My guest is Julia Selker, Executive Director of the WATT Coalition. WATT stands for Working for Advanced Transmission Technologies, and it's one of the most important advocacy groups for innovations that improve existing transmission efficiency. Julia began working on energy issues as a House of Representatives intern in 2018, and she's worked in the power sector ever since, despite having demonstrated excellent judgment in other areas of her life. In this USEA podcast, we're going to talk about the recently released Department of Energy, or DOE, report, Pathways to Commercial Liftoff for Innovative Grid Deployment. The paper describes how something called grid enhancing technologies, often called GETs or GETs, and transmission rewiring, called reconductoring, can significantly streamline the flow of electricity through the power system. And it can be a key cost-effective bridge until critical new transmission to meet U.S. climate and energy goals is finally built. Julia, let's start with why there's this need for grid enhancing technologies, or GETs, before we get into the technical definitions. Transmission and clean energy developers are stuck waiting for policymaker solutions for clearing the huge backlog of project applicants who want to connect to existing transmission or propose but not yet permitted new transmission. Why are GETs a way to address that?
Hi, Herman. Yeah, totally agree. We need more transmission capacity and we need new lines. Some of the other obvious measures of this urgent need are load interconnection backlogs. It's not just generators, but also new demand that is trying to connect to the grid. And then we also have a measure called grid congestion costs. So when there's not enough transmission capacity to deliver the lowest cost energy, you have to turn on higher cost generation, and we estimate that costs the United States $20 billion in 2022. So that number has been growing really fast. So we need new transmission capacity, and we need it as soon as possible. And grid enhancing technologies can get on the grid very quickly. One example is a dynamic line ratings deployment went from the start of the pilot to commissioning a full deployment in less than a year. And then once the systems are updated to use grid enhancing technologies, the software is updated, the staff is trained, the installation of a DLR sensor can take less than a minute. Of course, you have to procure the devices and everything, but these go up really quickly. So the speed is one thing. And then they're also incredibly inexpensive. So large transmission is expensive. It takes many, many years to pay for itself. Of course, it does many times over eventually, but the grid enhancing technologies cost 1/20th to 1/200th as much as a traditional transmission upgrade.
Wow.
So the cost difference is significant. They're the cheapest solution to increase transmission capacity, and they're the fastest to deploy. So what we would hope is that these would be the first tools that utilities go to increase transmission capacity. Now their inclusion in a liftoff report that's about commercializing or increasing adoption of commercially available technologies implies that there are some problems there, and the DOE the report suggests that within 3 to 5 years we want to get 6 to 12 deployments, like flagship deployments. For GETs, we think we'll have 6 to 12 flagship deployments in 1 to 2 years. There are a lot of other technologies covered in this report, but we're moving at a much faster timeline. But we're not talking about flagship deployments. We want them in the toolbox, like ready to be used by all the utility teams that can make use of them.
Well, it's obvious that we can use things that can do something about the backlogs and the queues. And for listeners, we're very soon going to be talking to someone from Lawrence Berkeley National Labs who's an authority on those queues and what's happening with them. They're growing. Spoiler alert, they're growing. But let's come back, and we're going to get to some of these obstacles and why DOE expects this to take a long time and why you say it can take much less time. But before we go further, there's 3 primary types of GETs. One you mentioned, dynamic line ratings. Another is called advanced power flow control. And another is called topology optimization. Now, we're not engineers, but in the simplest possible terms, can you tell us about those things? Why do they streamline the flow of electricity on existing wires?
Yeah, I think the easiest way to think about it is with a traffic metaphor. So, dynamic line ratings are kind of like opening up a new lane on the highway. Right now, transmission owners use maybe static line ratings that are the same year round. They're required by FERC to implement ambient adjusted line ratings by next year, and that takes into account temperature. And because when you run power down a line, it heats up, the air temperature and other factors cool that line. So AAR, ambient adjusted ratings, usually give you like a 10 to 15% boost on your line capacity. But dynamic line ratings also include wind speed and might measure the response of the line to these ambient conditions. And so these are more accurate than AAR, first of all, significantly. And they can usually add then another 10 or 20% above AAR. So one DLR deployment found a 40% average increase in line capacity. And Belgium has had the most DLR deployed for the longest time. They say they get an average they say they get 20% or more additional capacity over 90% of the time. So
Wow.
that's a big benefit. So then advanced power flow control is sort of like a traffic controller. You put them at these devices at the substation, and they can pull or push power onto different circuits. So if you have one line that's overloaded, because it's the shortest path to load, these devices can actually help the power take a detour, but still be delivered. So, potentially unlocking much more capacity. You're using paths that weren't previously accessible. I can share some case studies, but topology optimization software is like Google Maps for the grid. So the grid operator looks at this and says, and it shows the grid operator different interventions they could take to even out the flow of power over the system. So if you have one line is overloaded, there can actually be some pretty counterintuitive options for how to get around that traffic jam. And so the topology optimization software shows the grid operator what those options are. And yeah,
Interesting.
those are the devices and
So
technologies.
I like your analogy of traffic control, and it's like one street, a set of streets, and then the entire system through all these, and it's all software. And like you said, it can be installed once the process for managing them is present, you can add them very quickly. But the DOE paper
Mhm.
especially stresses Get's ability to increase the flow of electricity during peak demand periods with relatively little marginal cost compared to building new infrastructure. So is that a good focus? Or, I mean, certainly if you can reduce peak, you can cut costs and you can make systems more reliable. But what about the rest of the time? Um, how have Gets served in real world cases?
Yeah, so I think that emphasis on peak corresponds to the emphasis on peak in transmission planning. You're planning for worst case scenarios. And for many years, that also essentially addressed efficiency all the rest of the time because you were ready for the worst case and it wasn't the worst case. But in a more flexible grid with variable generation and a grid that's or demand and generation is changing faster than the grid can change, the flexibility from Gets is really important. And the system planning should go to looking at 8,760
hours.
hours.
Yeah.
Every hour of the year, they should be thinking about serving demand. Because some of the most expensive congestion these days comes at the shoulder seasons where there's a lot of wind and there's lower temperatures, but a lot of solar in spring and fall. So peaks are still important, but all the other hours of the year are important as well. However, Gets definitely have application in peaks. So the PPL electric utility is really the golden example of Gets deployment in the US. They put dynamic line ratings on just 2 lines, but they fully integrated with the PJM market. So that's their leap forward.
Mm. That's in Pennsylvania, right?
That's in Pennsylvania, and they were awarded the Edison Electric Institute's Edison Award for that, which is kind of the highest honor in innovation there. So
Interesting.
they projected that installation would save them $20 million a year in congestion. And because of Winter Storm Elliott and the constraints on available generation, the DLR actually kept them from having to curtail generation and redispatch. And that meant that it saved them $60 million in the
Wow.
first year rather than 20. So that's an example of a peak condition where DLR saved the day. And then National Grid is deploying 48 smart wires, advanced power flow control devices at 5 different substations. And they together balance out flows on the grid such that they can interconnect 1.5 gigawatts of new renewable energy. So that capacity is not necessarily dynamic. It's just controlling the flow of power. It's there at peak times. It'll be there. So GETs make use of the dynamic grid conditions, but the capacity increase they add is not always dynamic.
Those examples are just perfect for understanding that the whole system is changing. The whole system is becoming more dynamic. And all these devices, they can be much more than a bridge. They can address all the new dynamics of variable renewables and customer load fluctuations. There's so much potential. And there are these examples, excuse me, of proven successes. So why has deployment been so limited? What are the barriers? Is it regulation? Is it the way utilities think about investments?
Yeah, all of the above. We see two key issues: inertia and incentives, and they have a feedback loop between them as well. So on inertia, change is hard. There's a cost to change. People have to be retrained. Systems need to be upgraded and modernized. And frankly, the utilities have a lot of top priorities. The RTOs have a lot of top priorities. So yeah, I've been working on GETS for more than 4 years. And my view is until GETS become a top priority, we're not going to see that real change that we need to see. So we have to overcome this inertia. And feeding into that inertia is an incentive problem because utilities aren't compensated for reducing grid congestion or interconnecting generators faster and cheaper. That doesn't affect their bottom line, really. They make money based on the cost of their system through a return on equity business model. So, and there isn't a direct mandate for anyone to make the system more efficient. Even the RTOs, it's a nice to have. They're supposed to enforce just and reasonable rates, but it doesn't get to the top of their list, like I was talking about with the inertia. So we really need either an incentive change, and that could look like, for instance, a shared savings incentive, which is based on a successful regulatory change in the UK, which actually led to that smart wires deployment I was talking about, where the utilities.
You're talking about performance-based regulation, right?
Exactly. So if the utility finds a solution that is much lower cost than a traditional solution, but it creates benefits, they could potentially be rewarded with a fraction of those benefits as their compensation rather than the return on equity model they would have gotten for the larger investment. And so that worked in the UK. We think it could work here. We've submitted a proposal to FERC on that. And then federal legislators, Senator Peter Welch from Vermont, Senator Angus King from Maine, Representative Kathy Castor from Florida, and Tonko from New York, and Kasten just signed on to the bill as well, and Scott Peters from California. So a slew of legislators introduced legislation that would push FERC to undertake that shared savings incentive structure. So that's really the strongest direct incentive idea we have, but the public pressure from reports like this DOE report and from their regulators and everyone to say utilities, like, let's see movement on this, also helps.
Listen, we're almost out of time, Julia, but I would like to just go one more step on this regulatory question. And I'm going to have to get some of these folks to talk more about. We've had podcasts on performance-based regulation, but we don't address it as much as we can. And we're going to have to get some of those folks on. But one more step on the regulation. Do you have any particular ideas besides performance-based regulation, things that could be done at FERC or at the state level that could help? Just briefly.
Yeah, so there's some stuff FERC's already done, but I'll look to the future instead. There's both incentives that I described on FERC's plate that they're technically required to implement an incentive from legislation back from 2005, but they've also been exploring a requirement. So you could be required to deploy dynamic line ratings if your thermally limited line is creating 500,000 or $2 million of congestion every year. You know, if you're seeing those kinds of numbers, you kind of know the DLR is going to pay for itself. So they've taken stakeholder feedback on that idea, and hopefully that could become a proposed rule. So yeah,
Okay.
that's our other angle.
Well, I've really enjoyed talking to you. I think it's been a great and informative conversation. I got to thank my guest, Julius Selker, Executive Director of the Watt Coalition. He's been previewing the new DOE paper on how to get GETS to work, increasing power system reliability and lowering customer bills in the process. As always, I also want to thank our listeners for taking the time to check out the USEA Power Sector Podcast. Don't forget to subscribe, like, and share with everybody you know our quest for energy transition solutions.